Thank you everyone for coming to our talk. I'm David, and I have Manuel with me. We'll go through intros in a little bit. We're from Pinterest, and we'd like to talk to you about some of the learnings that we've had from modularization. Like many other companies, we kind of went through the same path. We started with a single app. It got too big, and we broke the code down into smaller modules. And we most recently, earlier last year, we completed our modularization. So in this talk, we wanted to share some of our learnings and some of the things that we wish we would have known before we started this journey. Things that we kind of wish we would have known at the very start. And hopefully, you can take some of the things that we've given you if you're at similar crossroads. So before I kind of go into this talk, I also want to tell you about my journey to San Francisco. So I live in LA, and when I was coming up to SF on Wednesday, I was supposed to go out at 7 a.m. My flight got canceled, and I got booked on the 9 p.m. I was pretty bummed because I wanted to make it to the speaker's dinner. So I talked to a travel agency and got it rebooked for 2. Ultimately, that flight got delayed by an hour. And when we were in the air, SF asked us to do a couple laps. So kind of like modularization, I knew where I wanted to go to. I wanted to come to SF, but there are a lot of bumps and scrapes along the way. And from this trip, I learned that, I should probably budget an extra day if I'm going to go do a talk, right? So just a quick little intro. I'm an Android engineer on the mobile builds team, and I've been at Pinterest for about 2 years. I've been doing Android for 10. I've been in mostly like the developer productivity space for about 6 years now. And yeah, in my free time, I like to spend time with my family. Over there, I'm doing a hike with my kids in Palm Springs, and if I wasn't a software engineer, I'd probably be a famous chef. But that name's already taken. And I also do like going around and trying new food. And pass it to Manuel.
Right, thanks, David. My name is Manuel. I am an EM at Pinterest, so I work very closely with David in the same team. I used to be an Android developer, so before David got started in the company, I used to do his role in the team. And in my free time, I enjoy doing activities outdoors, like all kinds of things. On the left side, it's not very easy to see, but I'm doing scuba diving. In the middle, I'm doing some, rock climbing in a gym. And then on the other side, I am in, I think it was Torres del Paine late last year, so I enjoy doing some hiking as well. All right, before I get started, I want to go quickly through the agenda for today. So first, I'll go through the reasons why we got into this journey in the first place. And then we'll talk about the journey itself, right? How it went, what we did to refocus our attention to get the results that we wanted, what's coming up next, and share a little bit of our learnings in the retrospective. So why are we doing this? One of the reasons why teams go through modularization is because they want to improve build times, right? The idea of splitting a big monolithic code base into smaller ones just makes sense, right? Like you split it, you are able to use the threads of your laptop, and then you get parallelization. The compilation work should be faster, right? In our case, that was also our goal, right? But as David mentioned, right, it was a road that had some bumps in the way. In fact, things also got worse before they got better, and we didn't really understand why it was happening. So the perspective of this talk, just to make sure, is going to be from the lens of a build engineer or someone who cares about making builds as fast as possible. So we won't really go into too much detail about how you can modularize, right? What's the right size of a module, things like that. So first question, right? Should you even be modularizing? And I think this is also a tricky question, like in engineering, everything depends. Say you are a small startup, you are trying to find market fit. maybe it's not a great idea to start spending too much time trying to modularize, right? I mean, maybe you don't have, you have a very small code base. It could be easier to start doing it, but then it also adds a lot of overhead. We have this saying, right? We don't want to prematurely optimize for things, so this is one of those cases. But maybe you are in a bigger company, your code base is big, your developers are reporting that they are unhappy because they are becoming ineffective of their work because build times are so big, right? So are so slow. So maybe at that time, yeah, it's worth to start thinking about this. And to provide some context, in our case at Pinterest, we started modularizing when our P50, which is more or less the build time that most people will see, was around 1.5 minutes. Our P95 was almost 15 minutes. So at that point, we were starting to see developers who were unhappy. Some people even say, maybe I'm so frustrated, I might change to the dark side, iOS. But hopefully nobody did that. To provide more context, right, this is the scale at Pinterest, just to get a sense. We have 1 million, well, this is for Android, so we have 1 million lines of code, approximately 10 of thousands of builds per month. We have about 100 of contributors and thousands of commits per month. So modularization in the early days. So as I said, right, like we got these bad build times, but we also know that modularization takes a really long time. I think in our case, it was about 2 to 3 years. But we needed to do something right now at that time. So this is a phase where we were looking for some quick wins. We focused mainly on enabling caching. So there's a lot of settings that you can tweak in your Gradle configuration file, in your Gradle properties file. So those are some things that we did. And even though we know that it wouldn't be very effective in every situation, there were some where we got some wins, right? Like when we were doing clean builds locally, when we were doing clean builds out of the main branch, then we were able to take advantage of the remote cache. So we were able to get some wins in some situations like that. And here is what we got. So for local builds, right, anytime that people were building locally and were able to take advantage of the local cache, we got a 9x improvement, where we went from 450 seconds to 50 seconds. So that was a big one. And then when people were doing clean builds and they were able to take advantage of the remote cache, we were able to get improvements of 3x. So from 9 minutes to 3 minutes, that was a big win in those situations. In case you want to get more details, right, about how we were able to get through these and other things, I have this talk that I did 2 years ago, how we brought down our build times, general optimization tips here, actually on droidcon SF. There's a link there, so in case you're interested, please feel free to scan it. All right, next. So after we went through, you could say, our first phase of modularization, the expectation, right, is that things will get better. But did it really get better? Well, turns out that as you modularize, you get more parallel compilation, then things can also get worse. And one of the main reasons why this happened is because we found out that as you have more threads working, your computer will overheat, and it has this safety feature, thermal throttling, which means that CPUs will automatically limit the power once it reaches a certain thermal limit. And this was really bad back in 2021, if I remember, when we were on Intel machines. So switching from Intel to M1 is also a really big win that you can do. So if you have that chance to do it, you will get a lot of benefits and yeah, much faster builds. So yeah, but also, right, at this time, since we saw these issues with thermal throttling, we were already enabling cache. We had to find out other opportunities for improvement. And this is where we started betting on avoiding unnecessary recompilations. And what does this mean, right? So to give out some examples, in our case, we were modularizing, but we were still coding in a way where, like if we had a very monolithic app, this means that we were having a lot of changes in very deep modules, like for example, a very big models library that sits at very deep in the graph. So that was causing a lot of recompilations. On top of that, we also had some issues with the Jetifier, which was causing some almost random recompilations. We also had some code generators that was having undeterministic behavior, which was also causing unnecessary recompilations. So in this stage, we focus on fixing this to avoid unnecessary recompilations and be able to take advantage of the cache that we had previously enabled. And you can see the improvement that we got here. So we were able to speed up our P50 and P90 by almost twice. This is where we went a P50, again, the build times that most people will see in the team from 1 minute to half a minute. For the P95, we went from approximately 14 minutes to 6 minutes. And again, there is a talk where I go into more detail about this, the different things that we were able to fix, how we brought down our build times, modularization impact on build speeds and metrics at droidcon New York in 2022. And here is a link in case you are interested. All right, now I'll pass it to David so that he can keep talking about our journey.
Thank you, Manuel, for that. So yeah, I'm going to be going over when we refocused our efforts during the modularization phase. So during modularization, we actually had created a helper script to create a lot of the scaffolding for modules. This would help our engineers kind of get off the ground with the build.gradle file. It'll pull in a lot of the common dependencies that you would typically need to build the app, and also create a couple of classes for you. But this came with a trade-off, and it was basically cargo culting a lot of dependencies that we really didn't need for those modules. And in this demo, I'll show you that you can grab the Now in an Android app, and I'll be adding a necessary dependency to one of the modules. And we do also use the dependency analysis Gradle plugin to run on CI. And what we do with that is anytime there is an unnecessary dependency that gets added on a PR, we would fail that build. So this helps make sure we don't add any new unnecessary dependencies into our graph. And so, in the Now in an Android app, we'll go ahead and add the dependency analysis plugin in the versions.toml and the root Gradle file. And then in the core notifications module, we'll go ahead and add the analytics module. So a very contrite example, and this will show the output of the dependency analysis plugin task called Project Health. This shows the before picture. And also, you can configure this to baseline some of these, or you can also make it ignore. So like these are third-party dependencies that in a real project, I would probably just ignore these. But what's interesting is in the after, where after I added the analytics module, it will actually point it out, right, that this is an unnecessary dependency. But why should you care? How does that actually impact the builds? So we are a Develocity customer, and we use Develocity for our builds. And in this build scan, you would see that it does show 0 tasks and 0 transforms. And the reason for that is because I added a filter for looking for the core analytics module, the new one that I had just added. And this is in the before, and in the after, you will see that 26 tasks were added, and is about 2 seconds, right? And this actually translates to about a 20% increase in your build. And if you add this all up throughout your app, this can get quite costly. And And if you're using smaller slices, like if you're just running the core notifications module directly, then you'll see this impact even more. And also, like if you were to use something like a sandbox or shell app, which I'll be talking about next. So another thing that we focused on was shell apps. Some other companies might call this a sandbox app or a playground app. This is essentially a slimmer version of your main app that you can launch a feature directly into. And the purpose of this is so that you can have much fewer dependencies that you need to build, so a much smaller build graph in this shell app. And just for a very simple explanation on how you can maybe achieve this as well is in the, let's say in the Pinterest app here, go ahead and try to use the pointer. Nope. It's kind of hard to see, but let's say you want to have a shell app living side by side with the Pinterest application. It would need to actually have the crash reporting library because, you know, maybe if you don't have this, other feature modules that are using it would actually end up crashing when you actually do launch them, right? But you don't want to pull in the real thing because that would actually slow down your build, but you want a fake one. So then what you can do here is you would have the shell app instead have a dependency on the fake crash reporting, which would have it implements on the crash reporting interface. And the base application would also put another line. I'm just going to stop using this pointer. I'll put another line between the base application to the crash reporting to just really enforce that contract. So now you could have a shell application that will be able to launch your features and it won't crash at runtime because let's say those feature modules depend on a crash reporting. But at this point, you've inverted that dependency and you just have it depend on a crash reporting interface instead of pulling in a ton of extra modules. And so this is an actual representation of the Pinterest app build graph. It's quite large. We have about 450 modules. And you can see also some of the nodes are a little bit larger as well. We've configured, Jeffy is what we use here. Gephi, if that's how you like to pronounce it too. And you can configure it so that a node that it has a larger between centrality, which is the edges that are coming in and coming out of that node, you can make that larger. So some of these nodes are a little bit larger. And we do have a node that we actually call hairball. And if you can spot that one, kudos to you. I can't find it in this graph, but it should be the largest one in there. And so when we go from the main app and we actually go into the shell app, we can actually drop about 75% of those modules. And that actually translates to about 40% reduction in build time. So that's what it looks like in our shell app. And just for context, like let's say our P95, right, is about 6 minutes for the main app, and our shell app is about half that time. So it takes about 3 minutes to build. But then in that case, you're only launching one specific feature instead of the full app. So I'd like to talk about what we're going to be doing next. In our modularization effort, we've mainly focused on our source code, but we didn't really touch any of our tests. A lot of our tests are still living in a monolith. So we have roboelectric and integration tests. They just live in a single module. But we've noticed that that is starting to cause a bottleneck in CI. So we're going to be splitting those up as well, putting them into smaller modules and then sharding them on CI. We've done a little bit of work with module score. If you don't know what module score is, it's something that we've learned from Slack about. And actually right now, Valeria is going to that talk. You can leave this talk if you want to go see that. I'm just kidding. But do watch that VOD. Basically, it takes the heuristics of each module. And so it uses information like the betweenness centrality, whether you're doing code generation and if you have Java or Kotlin, and it tells you how healthy this score is compared to other modules. What we can also do with this is also determine, because a lot of our scores determined by the between centrality at the moment is really dominating most of the score. It tells us like which of these modules are candidates for us to break up. So this is something we kind of wish that we had done before modularization. We actually didn't do the module score stuff until we were pretty much done. But at this point, we do want to continue using the module score or the module score to help us determine which new modules we want to use to break up. And we can also introduce into CI to say, like, let's not regress these module scores more by like 10% or something. This is starting to becoming a pretty common knowledge, I would say, within the Android community, is to split up your modules by API and IMPL. This is something that we also haven't really done too much effort in, but this is something that we're going to consider and look into moving forward. But I think this will be a really great win for further modularization and also improving our build times. And also just generally splitting up some of our bigger nodes. So we already know we have a node that we call the hairball module that has a large portion of our code. And when we look at our build scans, a lot of the bottleneck ends up in there. So like for context, this node is probably about like, I would say, 8 times larger than the next largest node. And now I'd like to pass it to Manuel, who will talk about how we share some of these learnings with our iOS team, since we're constantly learning, and they actually did the modularization project a little bit after we did, so they're able to take some of our learnings.
Right, thanks, David. Yeah, so as David said, I will share a little bit of the learnings that the Android team was able to share with the iOS team, right? Since they were starting, the iOS team was starting to modularize right after the Android team was pretty much done. The first learning is to have the right metrics. And when I talk about the metrics, I want to really emphasize, right? Because a lot of times, teams might focus on metrics, the easy metrics, and this could be things like what's the progress of modularization, right? How many modules have we modularized? Which is good to have, right? You want to know when you are done with your project, but you should also take into account the objective or the impact that your project wants to have, right? So in this case, it's also very important to, just like you are showing progress through metrics, you want to show your impact through metrics. And for this, you can do things like, right, if your objective of modularization is to bring down build times, then you should try to find some metric that will allow you to keep track of that, right? For example, try to measure just build times, or if that's not enough, maybe try to measure the percentage of cache hits, some kind of metrics that allow you to measure the impact of your project. The second thing that we also learned and shared with the iOS team was to have clear goals and definitions of success. And this is very related to the first point, right? Like, the objective of modularization is to have better build times. There might be other things like, say, have a clear boundaries between modules, so that then if you have a company that has multiple teams, it's easy for each team to know where they can contribute. That's also helpful, right? And then also have a definition of success for this as well, right? Like, if you want to improve your build times, okay, yeah, maybe this is the goal where we want to reach. Maybe we want to reach a percentage of cache hits, or perhaps for this other goal of trying to have better separation of ownership. Perhaps one way to measure this is if people are able to review their code and they only review the code that they own and they don't have to do that for other teams. That could also be another way to measure this. So it's always good to try to think about these things, and also keep in mind, right, that metrics is good to measure your success and your impact, but also remember that it's not doing the actual work. So try to find metrics that are not too costly to calculate, but are able to give you the right information that you need. And the last one is pay attention to the dependency graph health. So as David was talking about, right, he was mentioning module score, things like that. This is something that we started paying attention in the Android modularization project too late into the process. So at that point, it was very hard to make any significant changes. But for iOS, we were able to get these learnings and start paying more attention from the get-go. Actually, they come with some really good dashboards that I want to share next. So in this table, you can see the number of changes and depth for each module. So for example, in the first one, being close up, I'm not sure if you can read it, but yeah, it's the first module. You can see a red square. That means that it's a module that has a lot of changes. So in this case, for your dependency graph health, what you want is to have, you want to avoid having too many changes very deep in the graph, because otherwise you will have a lot of recompilations, right? So in this case, if you have a module that has a lot of changes, hopefully it's at the top so that it doesn't cause too many recompilations. And then for the modules that are super deep, like in the second column, you can see the depth. So for things like, say, ping models that is red on the second column and has a depth of 36, you want to make it as stable as possible. And in this case, we are not there yet, right? Like we have 164 changes. I think this is per week. So that's still too much. This is something that, thanks to this table, now we are able to see where are the hotspots, and now we are able to make improvements on the dependency graph. Next, this is another dashboard where we can see the centrality of the modules. And what this means is how many ancestors and how many children does a module have, right? So in a healthy dependency graph, ideally, you have something where it looks very flat. You don't have a lot of children, you don't have a lot of ancestors, and that way you can avoid recompilations. So in this case, you can see that there are some blocks that are very big, some that are very small. So ideally, most of them look at the same size so that they have an equivalent number approximately of children and ancestors. And then in this last one, this is another way to visualize the dependency graph. So in this case, I was talking before about ping models, right? Which is a module that is very deep in the graph, but has a lot of changes. So in this graph, we can see which are all the modules that ping models causes to recompile. So it's 223, so that's a lot of modules. And we knew that, but now you know which modules it's affecting, and so you are able to visualize it and try to make the appropriate changes for this. So just to recap all the learnings that we have from modularization, first one that I spoke at the very beginning, modularize when it makes sense. And this is, again, very tricky, right? You don't want to do it too early. You don't want to prematurely optimize. But also, you don't want to do it too late to the point where developers might be thinking about switching platforms or things like that. Second is measure. I mean, I talked about metrics, how important they are to measure your impact, your progress. At the same time, you need to reach a balance where you are not spending too much time coming up with metrics. So you have to be creative at times, try to see which metrics are available, which metrics will give you the right information, and use them to measure your impact and your progress. The last one is focus on quick wins, but keep an eye on the dependency graph. So, for example, right, things like, say, enabling cache, making some fixes, or even avoiding recompilations, those can be things that might be things that you spend a week or so, and then you have impact right away. And those are things that you probably want to focus first when you're going through this journey and you are trying to improve your build times. But then there are things like, say, shell apps. I mean, shell apps show a lot of great promise, but it's also something that requires a lot more effort. And then it can at times get a little bit challenging because you also require developers to have adoption, right? So I think that you need to think about which efforts are going to require the least effort and have the greatest impact so that you can prioritize accordingly and get the the wins that you're looking for. And with all, I want to thank David for speaking with me today. I know that this is the first time that he does public speaking, and I think he did really well. And also I want to thank to the audience for being patient. I know that lunch is coming soon, and it looks like everybody stay here, so thanks a lot for that. And with that, I want to open it for Q&A.